your physics teacher has given problem to find DC voltage and AC voltage. Which one do you find easily? Yes, absolutely, DC voltage, because it dealt with only real numbers, because it has only magnitude and there is no phase shift, right? But AC circuits use sinusoidal voltage and current, which has both magnitude and phase shift. Then how to make this calculation easier? In this case, we use the complex numbers to make the calculation easier and the representation less complex. Let us focus on how to represent this complex number. Usually, we represent a point in two-dimensional space using xy plane. But complex numbers are represented on a different plane, which is called Argand plane. Now, what is Argand plane? The plane having a complex number assigned to each of its points is called complex plane or the Argand plane, which means the complex number x plus iy corresponds to the ordered pair x comma y, and it can be represented geometrically as a unique point, that is p of xy in the xy plane and vice versa. And the axis which is horizontal is called the real axis, and the axis which is vertical is called the imaginary axis. Let's have a glance at how it can be done. Take some complex numbers such as 2 plus 4i, which corresponds to what? 2, 4. Now minus 2 plus 3i, it corresponds to the ordered pair minus 2, 3. 0 plus 1i, it corresponds to 0, 1. Minus 5 minus 2i, which corresponds to minus 5 minus 2. 1 minus 2i, it corresponds to 1 minus 2. These points are represented on the xy plane by the points A, B, C, D, E and F. We can also represent the modulus of the complex number in an Argand plane. Let's see that. The modulus of the complex number is nothing but distance from the origin to the point. This is our point P of xy. And the modulus of the complex number x plus iy is given by root of x square plus y square, which is nothing but the distance of the point P of xy from the origin 0, 0. The point on the x-axis corresponds to the complex number a plus i0, while the point on the y-axis corresponds to the complex number of the form 0 plus ib. Next, let us see how to represent the conjugate of the complex number in an Argand plane. The conjugate of the complex number x plus iy is what? It is x minus iy. Its corresponding points are p of xy and pq of x, minus y. Geometrically, the point x, minus y is the mirror image of the point xy on the real axis. Now, let us concentrate on polar representation of the complex number. Polar form of the complex number is the representation of polar coordinates as real and imaginary number in the coordinate system. The real and the imaginary components of coordinates are found in terms of r and theta, where r is equal to the length of the vector, which is given by modulus of z, and theta is the angle made with the real axis. The equation of polar form of the complex number z is equal to x plus iy is given by z is equal to r into cos theta plus I sin theta. This is a polar form where x is equal to r cos theta, y is equal to r sin theta, and r is given by modulus of z, which is equal to root of x square plus y square. And what is theta? Theta is called the argument or amplitude of z, and it is represented by ARGZ. Now, let us discuss briefly the value of theta. For any non-zero complex number z, there corresponds to one value of theta in the interval 0 to 2 pi, which means the point P lies in the first quadrant and the value of theta lies between 0 and pi by 2. Now, for the point pi by 2 to pi, the point P lies in the second quadrant. So, the value of theta lies between pi by 2 and pi. Now, consider this figure. In this, it shows the theta value lies between pi and 3 pi by 2 because the point P lies in the third quadrant. And this one gives the value between 3 pi by 2 and 2 pi because the point P lies in the fourth quadrant. Now, let's solve one problem for a better understanding. Represent z is equal to 1 plus I root 3 in polar form. Remember, we have to do it in polar form. Now, we know that x is equal to r cos theta and y is equal to r sin theta. Now, substitute the values of x and y. That is, 1 is equal to r cos theta and y value is root 3. So, root 3 is equal to r sin theta. Now, find the value of r. R is given by modulus of z, which is equal to root of x square plus y square. Substitute in the values, we get root of 1 square plus root 3 the whole square, which is equal to root 4, and the answer is 2. So, we got r as 2. Now, use this value to find cos theta and sin theta. So, 1 is equal to r cos theta, root 3 is equal to r sin theta. Substituting the value of r is equal to 2 in this, we get 1 is equal to 2 cos theta and root 3 is equal to 2 sin theta. Again, 1 by 2 is equal to cos theta. Bringing here, we get root 3 by 2 is equal to sin theta. Now, we know cos 1 by 2 will be equal to sin root 3 by 2. From this, we get theta is equal to pi by 3. Alright. So, the final values are r, we got it as 2 and theta as pi by 3. Is it possible to represent all the real number as a complex number? Think. So, with that, we have developed an understanding of Argand plane and polar representation. Now, let's do a quick recap of what we have discussed.
Manorama Horizon. Learning made simple.